All right, so we're going to continue our talk about working with functions here, and today we're going to translate functions. And what we're going to do is a lot of the same things that we did with our shapes, all right? So our translations, our reflections, our dilations, we're going to do those same things to functions now, all right? And for the most part, you're going to see a lot of the same things happen with those functions, okay? So now what I would like you to do is just take a minute. You can pause the video and answer the opener here. And then we'll flip it back on and we'll talk about how this is connected to what we've already done with translating figures in the coordinate plane. All right, so hopefully, all right, when you look at this, when we look at this graph on the left and we get to the graph on the right, hopefully you said, okay, we go to the right, 1, 2, 3, and then I go down 1, 2, 3, 4, 5. All right. So we went to the right 3, and we went down 5. Now, if we think back to what we did with translating functions, we used this notation, right? And we would have said, okay, I went to the right 5 in the x direction, and I went down 5 in the y direction. And that's really the same thing that we're doing here. The only thing that's different is how it shows up in our equations. And the good news is that you can use a lot of what we already talked about with writing equations from Algebra 1 as you do this work. All right, so for example, this equation has a vertex of 0, 0. So it would have just been x squared. Its a value is 1. So that would have been the equation of the graph on the left. Now, knowing what we know from Algebra 1, we know that the vertex of this quadratic is 3, negative 5. So we would know to write it like that. And then once again, we can see that the a value is that first rate of change, all right? And so we can see, all right, the big difference here is how we write our equation here is always opposite versus what we did in our translating, all right, of our figures, right? So just a small adjustment with remembering, like, how do we write the equation of a function? All right, so now let's jump into a little bit of notes. All right, so we're really going to be looking at two particular functions the most, all right, which is quadratics and our absolute value function. Now, our mother function is y equals x squared. So the mother functions always have their center or their vertex at 0, 0, and they have an a value of 1. And so our mother function for the absolute value equation is that guy. All right, so vertex form is a small adjustment here, all right, would be that. And then for absolute values, very similar here, just like that. All right, so once again, just a quick reminder, quick review from what we've done in Algebra 1. All right, so but it's been a little while for some of you. For some of you, not quite so long. All right, so now when we look at this, all right, so hopefully you went through the Desmos activity, and hopefully you remember what h does, right? So what does h do to our function? It is a horizontal shift. All right, and then hopefully you figured out that k is a vertical shift, right? All right, so h moves things left and right. Okay, k moves things up and down. All right, so there's some basic information on our translating function. So now, let's go ahead and flip to the next page here. All right, and now this is page 34. I should have started with that earlier. We were on page 33 if you hadn't figured that out. All right, so let me just kind of adjust my picture here so we can see everything. All right, so now, once again, and I'm going to go through a couple of examples, but remember, you can use Desmos.com /calculator, all right, to help kind of check your work. All right, so now when we look at what we want to do here, we're going to start with our mother function. All right, and we're just going to go through a few iterations here of translating that mother function. So notice for the first thing here that I want to go to the right 4. All right, so I want to translate this graph 4 units to the right and 7 units up. All right, and so if I think about that, I'm going to go to the right 4 units, and then I'm going to go up 7 units. So there's my new vertex, right? And so we want to write the equation. And if we think about what we just did, all right, the a value for all of these right now is going to stay the same. So whatever the a value is here, we're going to just pull down. And so my new equation would be x minus 4 squared plus 7. And that's all you need. All right, so that was for part A right there, right? Okay, so now notice this one. We're going to translate this graph to 5 units to the left and then up 3 units. So 5 units to the left and then up 1, 2, 3 right here. There we go. And so that would be the vertex for part B here. And then once again, if I move to the left, now this is the tricky part. Remember, this is going to be x minus -5, so that's why it becomes a plus, right? So if we go back to our formula here, all right, so this negative is part of, all right, our vertex form. So when h is a negative value, it's going to make that a positive sign on the inside of our parentheses or absolute values. And then up 3 would be that guy. Now notice here, all right, this is going to go off my graph because I'm going to go 8 units to the right and down 10. So I can't even see that on my graph, right? But I know I'm going to go to the right 8 units and then I'm going to go down 10 units. And I can kind of visualize that in my mind. All right, so go to the right units. That means I'm going to go x minus 8 because this means that my new vertex would be 8, -10, right? So if I'm going from the origin, all right, to the right 8 and down 10, put my square on there and then a minus 10 right there. All right, and so that's really all that you have to do with this. All right, so now if I just go down to number 2 here, I'll do one more with you. All right, okay. And actually what I'm going to do this is kind of go back and forth. So I'm going to have you do A, all right, pause the video, do A, turn it back on, see if you got it right. And then we'll do B and C the same way. So go ahead and pause the video, do part A, and we'll see how you do. All right, so now when we look here, now notice the difference here is that we are at a different position than the origin. So you have to pay attention to where do I start. So notice I'm starting at -3, -7. And now I want to go 6 units to the right and 2 units down. So to go 6 units to the right, so 1, 2, 3, 4, 5, 6, and then down 2 units would put me way over here, correct? All right, so if you guys can see that. So you always have to pay attention to where I start. So what might be good is to go ahead and label your vertex. So my vertex is -3, -7. And so notice now, if I go to the right 6 units, all right, I would add 6 to that. So that means my new vertex, if I add 6 here, that would mean it's my x-coordinate is 3. And if I go down 2 units, now my y-coordinate for my vertex would be -9. All right, and so now I can just input that into my equation, all right, because the a value is going to stay the same because we haven't done anything, and we're going to get to dilations and reflections in the next couple lessons. All right, and then I can just input my new vertex in just like that. Okay, so now pause the video and do part B. All right, let's see how you did here. Now, once again, this is our starting point. We're starting at -3, -7. And I want to go to the left 7. Well, that means I would have to subtract 7 from my x-coordinate. So that means that my new vertex, all right, would start at -10. And then notice now I want to go up 10, so I'm going to have to add 10 to that y value. And that means that the rest of my vertex would be -10, 3. All right, and then y equals 3, and then x. Once again, we're putting in a negative here, so this is going to be a positive. All right, and then plus 3. And there might be enough room here. All right, we go off the graph here, so you can't really see it, which is why using Desmos, all right, will help you. All right, one more time here. So pause the video, attempt part C, and then we'll see how you did. All right, so once again, all right, I really like the idea of writing down where I'm starting, all right, just in case I can't see it all on my graph. And notice this time I'm going to the left 9 units. So if I'm going to the left 9 units, I need to subtract 9 from that x. And then I'm going to go up 12 units. I'm going to add 12 to that. So my new vertex should be -12 and 5. All right, so y equals 3, and then x negative, and a negative, make that a positive on the inside, and then I get my plus 5 on the outside. All right, so there you go. That's how we translate functions. All right, so finish the rest of the lesson. Be sure to check your work on the answer key, and I will see you next time.